Okay, guys. So remember, for absolute value, there's two answers, right? Because there's two numbers that have a distance of 14 from 0 on the number line, which is 14 and negative 14. So I have to set the inside, x minus 7 equal to positive 14, and x minus 7 equal to negative 14, and then solve. So add 7. And I get x equals 21 and negative 7. And then the second one, I have to get the absolute value by itself. So I'm going to add 10 to both sides. Oh, let's see. Add 10 to both sides. And I get the absolute value of 4x minus 2 equals 38. And then there's two numbers that have a distance of 38 on the number line, positive 38 and negative 38. So I've got 4x minus 2 equals 38, and 4x minus 2 equals negative 38. So add 2 to both sides, and I'm going to get 4x equals 40, and 4x equals negative 36. Divide by 4. X is going to equal 10 and negative 9. Okay, and then for the last two, we have some rules because they're inequalities, and we have two sets of rules. The first rule says if I have the absolute value of x is less than p, then I'm going to solve negative p is less than x, which is less than p. And then the second rule says if I have the absolute value of x is greater than p, I'm going to solve x is less than negative p, or p is less than x. Okay, so depending on what my inequality sign is, depends on which rule I'm going to use. And so for the first one, I have a less than or equal to sign. So I'm going to use this rule here, the first one. I'm going to slide this up. The first rule. And so that means I've got negative 26 is less than or equal to 3x minus 1, which is less than or equal to 26. So add 1 to both sides, and I get negative 25 is less than or equal to 3x, which is less than or equal to 27. Divide by 3 everywhere. That gives me negative 25 thirds is less than or equal to x, which is less than or equal to 9. And then I said I'm supposed to graph it, so 3 goes into 25 8 times. So if I count by 3s, 12, 9, 6, 3, 0, negative 3, negative 6, negative 9. So I've got a closed dot on 9 and a closed dot on negative 8 and 1/3. So it's just a little over halfway. And it's greater than that and less than 9, so it's in between. So I can answer that in, if I answered it in interval form, which is how you will answer it in your checkpoint, it would be bracket negative 25 thirds, 9 bracket. And I'm going to come back to checkpoint one more time before we're done. When we finish with this, so I can talk about how to answer again, because a few people emailed me about it. So I want to bring that back to this discussion. So the second problem is greater than. that means I'm going to use the second rule. So that says I have 9x plus 10 is less than negative 10, or p, which is 10, is less than 9x plus 10. So subtract 10, and I get 9x is less than negative 20, and 0 is less than 9x. Divide by 9. X is less than negative 20 ninths, and 0 is less than x. So if I was to graph this, 9 goes into 20 2 times, negative 2, so negative 1, 0, oh sorry, positive 1, negative 1, negative 2, negative 3. I've got an open dot at 0, and x is greater than that, so it's going that way, and an open dot at 2 and 2 ninths, so just after 2, somewhere in there, and it's less than that, so it's going that way. So if I was to write this in interval notation, it would look like negative infinity to negative 20 ninths, not included, joined with 0 to infinity, not included. Okay, so I want to kind of talk about, okay, so we're going to go ahead and start now. The first thing we're going to do is just determine whether the ordered pair is a solution for the inequality or not. So all we're going to do is decide if it's a solution or not. I think that we've done something similar to this in the past to determine if it's a, so I think we've done something similar in the last couple days on this. All I'm going to do is plug in my x value wherever there's an x and my y value wherever there's a y, and I'm going to find out if it's true or false. That's it. So that means I've got 5 times y, which is 20, minus 8 times 6, and that's got to be less than 40. Whew, okay, so 5 times 20 is 100, minus 48, it's got to be less than 40, so I think this is 52 is less than 40. True or false? Is that true or false? And I'm going to mark down. I think I remember who I let in. Lucia is here. And false. Yeah, that's right. It is false. I'll get the rest later. False, false, false. Yeah. So it's not true. Not a solution, right? So not a solution. That's it. That's all we're doing. Okay, so for the second one, same thing. 3, just remember that the first number's x, the second number's y, so make sure you're putting them in the correct places. So 3 times 8 minus 5 times 5 is got to be less than or equal to 0. So 24 minus 25 is less than or equal to 0. Negative 1 is less than or equal to 0. Yes, this is a solution. Right? That's all we're doing. Okay, so I'm going to give you a couple minutes to do A and B. So over this, it looks like everybody got these right. So I'm going to just X and Y. Oh, let's try with a pen instead of a highlighter. X and Y, right? So I've got negative 3 times 2 plus 2 times 9. It's got to be greater than 12. So negative 6 plus 18 has got to be greater than or equal to 12. So 12 is greater than or equal to 12. Yes, 12 is equal to 12. So this is a solution. Okay, and then on part B, I've got X and Y. So 15 times negative 1 plus 4 times 4, it's got to be less than 1. So negative 15 plus 16 has got to be less than 1. Is 1 less than 1? No. If that was or equal to, it'd be a solution, but it's not or equal to, so this is not a solution. Okay, nice job, everyone who's put in an answer. Good job. Okay, we're going to go to the next page. So most of this whole lesson is graphing. We're graphing inequalities, either one inequality on a graph or two. So there's a couple things we need to talk about when we're graphing an inequality. If I use a less than or greater than sign, I have a dashed line. Okay, and if I have a less than or equal to or greater than or equal to, I have a solid line. That's how I tell the difference between if it's less than or less than or equal to, is one line is solid and one line is dashed. So I have to make sure that you're doing your line solid and dashed. And I understand that we're not going to be able to put most of the answers on this for this in the chat box. Woo! Because you can't put a graph in there. We might just hold up our papers to the camera so I can see your answers really quick, and that might be the way we do it. We'll just do it all at the same time, and go like that. Do that. So the other thing we need to do when we're graphing, it needs to be in the form y equals mx plus b, just like we're graphing a straight line. So we want to make sure the y is by itself, identify my slope and my y-intercept, decide what type of line it's going to be, and then it's shaded. It needs to be shaded. And how we shade it, I'll talk about that as we go through, okay? So as we get to that part. So I'll talk about the shading as we get there. So the most important things to remember is that we're graphing it in slope-intercept form. It needs to be dashed, either dashed or solid line, depending on what the inequality sign is, and the graph has to be shaded on one side or the other if there's one, and then there's an area that's shaded. Okay, so let's go ahead and start with the first equation. It's already solved. Y is already by itself, so I can find my slope. My slope in this case is 3 over 1. So how do I turn a whole number into fraction? I put a 1 underneath it. My y-intercept is 0 because I'm not adding anything to it. So that's 0. So now, and what type of line do I have? I have a solid line, okay? Because it's or equal to, it's going to be a solid line. So let's see, I'm going to make this a little bigger. I hope you guys have this over here done. I'm going to make it a little bigger so it's easier for me to see and you guys to see. So I'm going to start at 0. And then I go up 3, 1, 2, 3 over 1. 1, I can go back 1, 2, 3. And I'm going to draw a solid line this time. So, okay. So now one side or the other of my graph is shaded. And this is why we started out with the finding out if a point is a solution or not, is I'm going to choose any point on the graph that's not on the line. So any point on my coordinate plane that's not on my line. Usually I choose 0, 0 unless my line goes through 0, 0. Unfortunately, my line goes through 0, 0, so I'm going to choose any other point. It does not matter. You can all choose different points because there's an unlimited number of points in the coordinate plane. So we could all choose different points, okay? So I'm just choosing one. I'm just going to choose one. And I usually try and get x to be 0. That means I'm going to choose something on the x-axis. On the y-axis. And why I want to choose, I'm going to tell you this. Why I usually choose x to be 0 is because sometimes my slope is a fraction, and I don't like multiplying by fractions or adding fractions. So I just like if I multiply that fraction by 0, I just know it's going to be 0. So I just like my x value of whatever point I'm going to be choosing to be 0. So I'm going to just choose something. We'll just say I'm going to choose that point right there, which is, that point is 0, 2. So I want to know if that point is true or not. So I chose the point 0, 2. And I want to know if that's a solution. Is this a solution? Okay. So we do what we just got done doing on the last page, or in the last directions, where it says plug it in and see if it's a solution or not. I have my x value is 0 and my y value is 2. So I'm going to plug it into my equation here, and I get, let's see, what do I get? 2 is less than or equal to 3 times 0. So it's 2 less than or equal to 0. Yes or no? No, it's not. So it's like, I had two answers, right? Either it was or it wasn't. And if you look at my graph, I have two sides of my graph. I have the side that contains the point that I just checked and the side that doesn't. So if my answer was yes, I would shade in the side that contained the point that I chose, but my answer was no, so I'm going to shade in the side. I'm going to try and get a bigger thing here. I'm going to shade in the side that does not contain the point. So it's this whole side over here. Okay? I think that's the hardest part that people have with the graphing part, is deciding which side to shade. So I just need to know, I just need to say this again. Once I pick a point and I plug it in, I have two answers for that. Either it is a solution or it's not a solution. And I have two sides of my graph, either the side that contains that point I chose or the side that doesn't have that point. So I hope that helps a little bit. We're going to try it again though. So here we go. Problem number 2. We're still doing exactly the same thing. I need to solve for y equals mx plus b. So this one I have to solve for y because it's not by itself. So I'm going to subtract, forgot I was still in highlighter mode. Subtract x from both sides, and I get negative y is greater than negative x plus 4. Y is not by itself, so I need to divide by a negative 1. And what happens when I divide by a negative number? What happens when I divide an inequality by a negative number? Yep, my sign flips. Beautiful. So it was greater than, now it becomes less than. And negative x divided by negative 1 is positive x. And positive 4 divided by negative 1 is negative 4. So now I'm in the form y equals mx plus b. So then I need to find my slope. My slope is 1 over 1. And my y-intercept is negative 4. And my line is going to be dashed this time. Okay? It's dashed because it's less than, not less than or equal to. So now I'm going to draw the line. Let's see, negative 4 up 1 over 1. Okay, and back. Okay, and then I need to draw a dashed line, so it just needs to be dashed. This takes a little bit longer to draw it. That's it. Just needs to make sure you have your holes in there. Okay, now I need to choose a point that's not on that line. Any point on the graph that's not on that line. And luckily, this time, 0, 0 is available, and I'm going to choose that one. So I chose 0, 0. Is this a solution? right? So I have two equations. I can plug it into either one. It doesn't matter. I can plug it into this equation here. I can plug it into this one, or I can plug it into this one. It doesn't matter. I'll get the same answer. So just choose one, plug it in. I usually like plugging it into this. For me, I usually just plug it into this one. I have no idea why, I just do. So there's no rhyme or reason. That's just the one I choose. You could choose the original one if you want. So then I've got 0 is less than 0 minus 4, and is 0 less than negative 4? That would be no. No, 0 is not less than negative 4. So I do not color in the side that contains the point. I color in or shade in, however you want to do it, the other side of the graph. Just like that. Okay? Questions? Okay, so doing it with one equation, not too bad. Doing it with more than one equation, little teeny bit harder. Okay, so this really, I'm going to break this down into two equations so we can graph each of them separately. I have the equation that says x is less than or equal to 5. And then I have, oh, that is so incorrect. Let me see if I can write that right. I have the equation that says x is greater than or equal to negative 5. And then I have one that says x is less than 4. So I have two equations. I can't put them in the y equals mx plus b because there's no y. So that means this is a vertical line. So I know it's a vertical line because there's no y in it. So the first one is at negative 5, and my line is going to be solid here. It's solid at negative 5. So I have a solid, if I can draw a straight line. Okay. So here's my straight line. And then it says, when I'm doing more than one line, you want to be careful and not color it or shade in everything all at once. You kind of want to maybe just draw some lines, or use pen and pencil, two different colors, or highlighters, two different highlighters, just something that's will have some sort of contrast for you. So this says x is greater than negative 5, which means it's on this side. And then sometimes when I'm drawing my lines, I do them at a different angle also. So that would be this one. And then because I can change the color, I'm going to. For the second one, I have a dashed line. Okay, and it's a vertical line at x equals 4. So dash, dash, dash. Got a little close on some of my dashes. There we go. So then I need to shade in this one, and it says x is less than 4, which means it's this side of my equation, this side of my line. And then the answer is where the two overlap. That's kind of why I did my diagonals when I was doing my shades at different ways. So you can see where they cross over is the answer that I would shade in. So, and you would think it's always between two vertical lines this way, and sometimes it is not. So, but here is my answer for this inequality or system of inequalities. Is there any questions so far? Is everyone doing okay? All right.
Miss Campbell?
Yeah, hun.
How do you know, like, in between the two inequalities, like that's where the dash is, or that's where you shaded in.
Okay, so you saw that when I let's see, how do I want to say this, Kim? So when I did the x is greater than -5, you know, it was on the right hand side of -5, right? So the orange lines, right? So oh, let me get this. So it was these orange lines. Are you okay with that part? So that was that part of for this one. That was what was shaded, right? And then what was shaded for this one was the green one. It's less than 4. So it's all of this part. And do you see where the green and the orange overlap? See where these, where you, the area, okay, how do I want to, sorry. I'm getting the words all messed up in my mind. This section here, if you look at this section here, it's only the green lines. And this section here is only the orange lines. And if you look at the middle section, it is the green and the orange lines. So where the lines overlap, that's the answer I want to shade in. Did that answer your question, Kim?
Yeah, thank you.
You're welcome. Okay. Okay, so I think I have, okay, now we're going to have you guys try. Okay? So, I know we have a little bit of time left, but I'm going to go ahead and start on the first one. And start doing that because I want to make sure that we have time to get through everything today. So, let's see. My slope is -4/1. Y-intercept is 5. And that's going to be a solid line. So, 5. 1, 2, 3, 4/1. Solid line. Yeah, I hear you. Thanks. Okay, then pick a point, any point that's not on the graph. I'm going to pick 0, 0. So is this a solution? So I'm going to plug it in, and I get 0 is greater than or equal to -4 times 0 plus 5. Is 0 greater than or equal to 5? Well, no. Wow, we're getting all the no answers. Okay, so that means I shade in the right side of the graph. I guess it's mostly the right side of the graph. Okay. All right, beautiful. And then if I'm going to do the second equation, any questions? Sorry, I went up really kind of fast on that. Is there any questions on that one, or can I go ahead and move on? Okay. So on the second one, I'm going to solve for y. So let's make sure I have a pen. Minus 3x gives me 2y is greater than -3x minus 2. Divide by 2. Y is greater than -3 halves x minus 1. So my slope is -3/2. My y-intercept is -1. And I'm going to have a dashed line. Okay, so let's see. I'm going to start at -1. And I'm going to go down 3. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, and it's dashed. Okay. Okay, pick a point, any point that's not on the line. 0, 0 is not on my line, so I can pick it. So I'm going to pick 0, 0. Is this a solution? So I'm writing that every time because if people miss class and are just looking at the notes, I have to go. Okay. Then I want them to know that that's what I'm using this point for. I want to say this is a solution. Is this a solution? So I'm going to plug it in, and I always choose this one. I don't know why. I'm sorry. Usually I can give you some sort of reason why I choose that one. I don't know why I choose that one. I just do. So, but you could plug it into either that equation. You can either plug it into this equation, like I said before, or this one. It doesn't matter. Just pick one of them and plug it in. So I've got 0 is greater than -3/2 times 0 minus 1. And then I've got 0 is greater than -1. Well, yes, that is true. Beautiful. Finally, for the first time, we've got a true answer. So I shade in the part that has that point. Questions? Everyone okay? All right, so now we're going to talk about a system of equations, which means more than one on the same graph. Although we've done one with vertical lines, now we're going to do them with non-vertical lines. So we're doing the same thing, using the same thing. If it's a dashed or solid, that hasn't changed. Nothing's changed except that I'm graphing two lines on the same graph. So I've got line 1. Sorry, line 1 and line 2. So I just kind of like labeling my graph, my lines, so I know which one I'm working with. So I'm going to do line 1 first. So line 1 is y is greater than or equal to x. So my slope is, it's already solved for y, so I don't have to do anything. So my slope is 1 over 1. My y-intercept is 0, and it's a solid line. Okay? So I've got 0, 0, up 1 over 1, and it's a solid line. Okay. So I need to pick a point that's not on that line. Any point not on the line. So I'm just going to pick this one again. What did I pick? I picked 0, 2. So now I'm going to plug it in. And it says 2 is greater. Why am I using a parenthesis? Comma. Is this a solution? So 2 is greater than or equal to 0. Is that true or false? Well, that is true. Yes, it is, right? It is true. So I'm not going to shade it in yet because I know I have another line to graph. So I'm just going to kind of, I should have used the same color so I can do my other graph in this color. Sorry. Okay, so there's that line. So now I'm going to do line 2. Line 2 down here is y is less than or equal to negative x plus 4, which is also already in the correct form. So my slope is going to be negative 1 over 1 over 1 over 1. Let's see if I can write correctly. And my y-intercept is 4. And then again, it's a solid line. Okay, so I'm going to start at 4 this time. Start at 4, do negative 1 over 1. So up 1, back 1, up 1, back 1. And it's a solid line here. to my straight line. So now I need to pick a point that's not on this line, and I'm going to pick 0, 0 because it's not on the line, on the pink line that I'm doing. So I'm picking 0, 0 and plugging it in, and I've got 0 is less than or equal to negative 0 plus 4. Is 0 less than 4, less than or equal to 4? Yes. Yes, it is. So I shade in the part that contains that point. And then the part that I really, really, really want to shade, that's where all my answers are where the purple and the orange line overlap. So where those two lines overlap, or the two different ways you draw your lines overlap, or if you use pen and pencil, wherever those two overlap and intersect. In here you'll have 4, when we're doing, most of the time, 98.9% of the time, you're going to have 4 areas, right? I have 1 area here, 2, 3, 4 areas. One of them will have no lines in it. 2 of them will have 2 of the, whichever direction you've decided to do your lines. If you decide to, maybe you decide to do them 1 wavy and 1 straight. I don't care, however you decide to do it. And then the other area will have both types of lines in it, and where they both overlap, that's the area I want to shade. That's the area that I want to shade in, because that's the area where any of the points in this area make this system true, or true for both equations. So that's what it's saying. So any point in this shaded area, make both of these true. Both of those true. Okay. Okay. So I think we have a couple more examples, or one more example, and then it's your turn to do 2 or 3 of them. I don't remember how many it is. Sorry. So again, I have equation 1 and equation 2, and I'm going to start with equation 1 again. So equation 1 is x is greater than, wow, negative 4. So no y, so I know that it's going to be a vertical line, and my vertical line is going to have a dashed line. It's going to be dashed, if I can spell it right, dashed, at negative 4. So I have a vertical line at negative 4. Okay. And then it says x is greater than negative 4. Greater than negative 4, it's either left side or right side. On vertical lines, vertical and horizontal lines, I really don't have to choose a point. I can tell which side is greater than or less than, because it's just like on a number line. Towards negative 3 is greater than negative 4. So it's this side. Okay. And then I'm going to do line number 2. Line number 2 says 2x plus y is less than plus 3. Wow, okay, then 3. So what I'm going to do first is, what am I going to prove? Oh, solve for y, yeah. So I'm going to subtract 2x, and I get y is less than negative 2x plus 3. So my slope is negative 2 over 1. My y-intercept is 3, and I have a dashed line again. Okay. So let's see. I'm going to start at 3, and I'm going to go down 2 over 1. And they want it to be dashed. Okay. Okay, pick point, any point not on the line. I'm going to pick 0, 0. So I picked 0, 0. Is this a solution? So plug it into one of the equations. It doesn't matter which one. either this one or this one. Just pick one of them. And so I've got 0 is less than negative 2 times 0 plus 3. And 0 is less than 3. That is true. 0 is less than 3. So that means on my line I'm shading in this side. Should have made my lines go the other way. But the answer is where the green and the orange lines are overlapping, which means, by the way, there is a fourth area on this graph. Remember on the last one I said there was 4 areas. My lines up here have not crossed, so once I get up here, this will be my other area, the one that doesn't have anything in it at all up there. I just want to show you that sometimes the lines don't quite give you a big area that cross. So here is the area where the green and the orange overlap. So anywhere in here, my answer is the solution for both answers. The solution for both answers. Okay, so now it's your guys' turn. I'm going to try and put them both up here for you. I'm going to go ahead and start doing this one. If you're not done with the second one, it's okay. So I have 1 and 2. So equation 1 says x plus y is less than or equal to 1. Subtract x. And I got y is less than or equal to negative x plus 1. My slope is negative 1 over 1. Y-intercept is 1. And it's going to be solid. So b starts at 1. And it's negative. And it's solid. Okay. Pick a point not on the, oh wow. Okay. Let's make that look more like an arrow. Okay, pick a point not on the line. 0, 0. So if I pick 0, 0, it's this a solution. I've got 0 is less than or equal to negative 0 plus 1. Is 0 less than or equal to 1? Yes. So okay. And then I'm going to do line 2. Line 2 says x minus 3y is greater than or equal to 9. Subtract x. Negative 3y is greater than or equal to negative x plus 9. Divide by negative 3. So y is less than or equal to, because I divided by a negative number, the sign switches. 1/3 x minus 3. So my slope is 1/3. My y-intercept is negative 3. And I have a solid line. Okay. So, negative 3 is here. Up 1, 1, 2, 3. 1, 2, 3. Did I do something wrong, Harrison? Oh, okay. I'm like, you know, I can do stuff wrong. So, okay. So did you figure out what you did wrong? I'm pretty sure the first one is 3. Negative 2. I'm not sure what I just don't understand your first line. Does that make sense? Okay. That I understand. Okay. All right, so there's my line. Pick a point not on the line. Again, I'm going to choose 0, 0 because it's not on my line. So I've got 0, 0. So 0 is less than or equal to 1/3 times 0 minus 3. So 0 is less than or equal to -3. 0 less than or equal to -3. No. So that means I shade in the side that doesn't contain that point, and where they both ooh, so sorry. Where they both overlap is here. Questions? Harrison, is there something I can explain better? Do I need to explain something better? Or are you okay now?
I'm just gonna watch another one just to see if I can kind of get this. I've been distant all morning, very blonde morning.
Okay. I've been there, so I understand that. So I've got equation 1 and equation 2. So equation 1 is 4x plus 3y is less than -9. Oh, okay, subtract 4x. Subtract 4x, so I get 3y is less than -4x minus 9. Divide by 3. And y is going to be less than -4/3 x minus 3. So my slope is going to be -4/3. My y-intercept is going to be -3. And then it's going to be a dashed line. So this part right here, you guys, that I just got done doing is just like solving for y, right? You guys have done that forever. You've put it in slope-intercept form. You guys should know how to put it in slope-intercept form. Don't let the inequality sign throw you off. You're doing exactly the same thing that you've been doing forever. Would you do that for me? So you should be able to do that part. Just remember, the only thing you have to remember is if I divide by a negative number, then the direction of my inequality sign flips. And that's the only thing different than if it was just an equal sign, if I was just graphing a straight line without shading it in. So the only thing different is, and then I have to graph it and then shade it. That's the different part here. So I've got -3 is here, and then 1, 2, 3, 4, 1, 2, 3. Okay. Oh no, down 4. Yeah, that's right. Or 1, 2, 4, 1, 2, 3, 1, 2, 3, 4, 2, 3. Oh, and it's a dashed line. Okay. Okay, pick a point not on that line. So I'm going to pick 0, 0. So I picked 0, 0. And I'm going to plug it in. And I'm going to write down here in the margin here. I've got -4/3 times 0. And I forgot that I have 0 is less than -4/3 times 0 minus 3. So is 0 less than -3? No. So that means I shade this half of it. Okay, I guess for line 2, I'm going to come over here and do line 2 over here. So I've got x minus 3y is less than -6. Okay, so subtract x. negative 3y is less than negative x minus 6. Divide by negative 3. So I divided by a negative number. So this is the only thing that's different than if it was an equal sign or not. Because I divided with a negative number, my inequality sign flips direction. So it was less than, now it becomes greater than. And then I have 1/3 x plus 2. So my slope should be 1/3. My y-intercept is 2. And again, I have a dashed line. Okay, great. So let me see if I can put it all on here. Okay, so I'm going to start at 2. 1/3. Up 1, 1, 2, 3. 3. Down 1, 1, 2, 3. The nice thing about Delta Math, you guys, if you're doing it on your own, is that now for most of the, oh, my Lanta, that was a really bad line. For most of the, they have show examples, right? And now for most of the assignments or the little topics, they have videos too that help. So not only, you don't only have to come back and watch my videos. If you get stuck or look at your notes, you can look at the videos that they provide, and that might be just a little different perspective than what I'm giving you guys, and you might understand it a little better looking at them, looking at the help videos on Delta Math if you get stuck. So not quite all of the topics have it, but most of the topics have help videos now. So that is a good thing. So I did I choose? I did choose 0, 0 again. Okay, so 0, 0. And then I've got 0 is less than 1/3 times 0 plus 2. Is 0, that is not less than, that's greater than. Is 0 greater than 2? No. So once again, I'm not shading in the spot that contains 0, 0. Okay, so that means that my answer is just, well, it looks like a little teeny spot on my graph compared to some of the other ones, but remember the lines go on forever and ever, so it's an infinite amount of answers that are in that little area. Okay, and I think we have one more. Oh, shoot. Okay. I'm not, oh, one more question. So go ahead and work on this one. This is the last one. I'll give you a, let's see how much time is left. I'm just going to go ahead and do it because there's only a few minutes left, so I hope you guys are okay with that. So I have question 1 and question 2. So I've got 5x plus 3y is greater than or equal to negative 9. Subtract 5x. And I've got 3y is greater than or equal to negative 5x minus 9. Divide by 3. Y is greater than or equal to negative 5/3 x minus 3. So my slope is negative 5/3. My y-intercept is negative 3, and it's a solid line. Okay, so I'm going to start at negative 3. Go down 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. Solid line. Good. While I'm doing this, you guys, there will be a checkpoint out tomorrow for these two. 2, 2, and 2, 3. Okay, so choose a point. 0, 0. Let's see, what do I got? 0 is greater than or equal to negative 5/3 times 0 minus 3. Is 0 greater than or equal to negative 3? Yes. So that side. And then I'm going to do question 2 down here, I guess. What is question 2 before I move that up? X plus 3y is less than 3. So subtract x. 3y is less than negative x plus 3 divided by 3. Sorry. Y is less than negative 1/3 x plus 1. Slope is negative 1/3. Y-intercept is 1. And it's dashed. Wow. Okay. So I'm going to start at 1. And it's negative 1/3. 3. Up 1 over 3, up 1 over 3. Dash line. Sorry, I know we're like right on the cusp of being out of time. So that's why I'm trying to rush through here. Sorry. Point 0, 0 is not on the line. So I've got 0, 0. And 0 is less than negative 1/3 times 0 plus 1. Is 0 less than 1? Yes. So in here, so it overlaps in this area. Okay. Beautiful. There we go. Sorry I had to rush the last one. I wanted to get it in there. If you need to go back and watch the video and watch it a little slower, please go ahead. It should be available tomorrow morning because I have to go to the school today for the basketball